Hey, everybody. Thanks for coming to our eCornell webinar today on hardware product development, the next maker revolution. We're thrilled to have you with us. In a moment, I'm going to ask our guest panelists to introduce themselves, but let me tell you a little bit about what we do here at Cornell around hardware product development. So I'm part of an organization called CREA, the Center for Regional Economic Advancement. So as well as being faculty in the Business and Engineering School, I'm involved with my colleague Steve Supron at Rev, which is a business incubator in downtown Ithaca, where we're a domain agnostic incubator, but we have a particular focus on hardware. And in that focus on hardware and hardware companies, we have a couple of programs that we're very proud of that have done very well. And one of the reasons we asked you all here today is to hear about those programs, and whether you're interested or you know someone who might be interested in joining one of these programs, we wanted to give you a chance to learn about them and then hear about some of the sort of pluses and minuses and intricacies and good stories and horror stories of folks that are trying to bring physical products, so products that involve atoms, not just bits, to market. So here at Rev, we have a few groups of programs. In the summer, Steve and I run an 11-week prototyping program now, where you really are going from an idea through to a prototype, working both on the technology and the business model. And we have 3 tracks in that program. We have a track that focuses on clean tech, so ideas that may reduce carbon, so either through different forms of generation or carbon storage to get rid of peak loads, things for the home to reduce energy consumption in the home or a vehicle or what have you. So we have a clean tech track for folks that are looking at ideas around greenhouse gas reduction and sort of the various ways one might do that. We have another track that's focused on ag tech or agriculture tech, which is everything from processing of food, things for the farm, to automate the farm, to control, to increase yield, to decrease runoff, to optimize fertilizer usage, and so forth. So our ag tech track is for companies focused on those areas. And then we have this open track, which is for companies that just don't fit in the other two, that have ideas that might be for the home or mobility or safety or sports. And we've had a number of teams through that. And we've done this program now, 6 times in the last 7 years. We took a year off for COVID. We also have a program for teams that actually make some progress and develop a business model, develop a prototype, raise some money, form a company, and are looking to go into manufacturing. And we run a year-long program around the sort of steps of going through into manufacturing. The process of prototyping something and testing that idea is very, very different than the process of reproducibility. Making something that you can make one of is very different than the process of making 1 million of something. So we have a program to help companies do that. And then Steve and I are also partners in some other programs specifically around helping clean tech companies move into manufacturing. So that's what we're all about, and that's why we wanted a chance to talk about sort of hardware product development today. And with that, I want to give our guest speakers a chance to introduce themselves. Our third guest speaker, who's from Australia, may or may not join us. There seems to be a technical glitch, but I'm thrilled to have the folks with us. So first, let me introduce Anna Thornton, and I'd love her to talk about herself for a couple minutes.
Hi, my name is Anna Thornton. So I started life as an engineer, ending life, my whole career has been as an engineer. So mechanical engineering, undergrad and graduate. I then went on to be a professor at MIT for about 6 years, where I worked in the Lean Aircraft Initiative and a whole bunch of manufacturing related spaces. So I did research in quality systems and manufacturing, and discovered that I liked the factory floor better than I liked writing papers and grant applications. I actually liked doing it. I didn't really want to write about it. It's great. I don't think I've written a report in 40 years or 30 years. Everything's on PowerPoint. I don't like, and then I wrote a book, which was the one thing of text that I wrote. So I then left and joined a consulting firm where I helped grow a consulting firm, about 4 people, and then we were sold to McKinsey. And there I did a whole bunch of stuff with larger companies. I went to Dragon Innovation, where I worked with small startup companies, hardware startup companies, bringing them into production in China. And that was a really great opportunity to really work hands-on with the startups. And a number of them are starred footnotes in the annals of companies that didn't make it. And then we have a couple that have been very, very successful and are standing products today. Right now, I'm a professor I've gone back full circle into academia, and I am a professor of the practice at Boston University, where I teach product realization, and I'm also the director of EPIC, which is our Engineering Product Innovation Center, which is a 15,000 square foot facility where we teach all of our hands-on courses at BU. We have somewhere between 1,500 and 2,000 students coming through that facility and learning about how to build things physically and how to instantiate their ideas. So sort of ideas into reality. So my passions are around getting companies to build hardware, to do it well, but to take the lessons learned from other companies about how to do it right to increase your chance of success. And I always use the analogy of the marathon. You would never run a marathon never having walked the path, or at least tried it a few times. And so you really do need to do your practice, learn about it, understand what you're coming up against, because it is a bit of it can be quite challenging to go through that process. And so companies can avoid mistakes and not run out of money if they do a little bit of the homework and the work ahead of time.
Thank you. I'm so thrilled you can make it. I sort of have crossed paths or known some of you for a very long time. I'm so thrilled you could be here. We are joined now by Saul Griffith, Dr. Saul Griffith. I'm thrilled you can make it, Saul. We're just the speakers are just introing themselves, so I'm going to give you a second to collect your thoughts, and I'm going to ask Joy Weiss if she could introduce herself and a bit about her background and her current company.
Thanks, Ken. Anna, hard act to follow. So hi, everybody. It's a pleasure to have the opportunity to talk to you. I'm currently the president and CEO at Tempo Automation. What we do at Tempo is we're trying to help folks through that new product introduction cycle by building, assembling electronics more rapidly than ever before with first-time right quality. And I came to this role through a long history with the company, actually. My background is I grew up in telecom, double E by training, ran a few hardware startups, and the last one was Dust Networks, which was pioneering the use of wireless sensor networking equipment for industrial applications. And it was acquired by Linear Technology, which was subsequently acquired by Analog Devices. In this ever consolidating semiconductor world we live in. And I started doing a wee bit of angel investing, and I was approached by the founders of Tempo Automation, who pitched me on the idea, what if we could make hardware development look a lot more like software development in terms of speed and agility? And they had my attention. I made a small investment and became an advisor to Tempo Automation, joined the board after they raised their first round, and Lux Capital led the very first round in the company. And Lux has a history of, there aren't that many venture capitalists that love hardware. Lux is pretty ambitious on that front and a great partner. And then a little later in our history, at the end of 2019, after we'd raised a few more rounds, I became CEO at Tempo. And it's been a great ride for the last couple of years, being back in a small company after a while in a large company. And what we're really trying to do is, harness data from every build to make sure that the next build we do is perfect. In other words, what you all might be designing, I like to think of as snowflakes. Every product that you design is a brand new realization of some combinatorial of components on a printed circuit board that will have some ultimate purpose and work in some particular environment. And so making a perfect small quantity of them is the challenge at hand that we try and solve at Tempo Automation. And we're doing that by creating a really automated front end so that we can speed the ingestion of your requirements and hopefully get some advice into your designs as quickly as possible, and then tying that front end right back into our factories, and then pulling the data from every build that we do and using that in turn to feed the front end. So it's a pretty virtuous cycle. Every build we do makes the factory smarter, and that in turn makes us better able to serve folks that are building small quantities of hardware. So this topic is near and dear to my heart, and thanks, Ken, for inviting me to participate on the panel today.
Thank you. I'm so glad you could make it. And Saul, would you mind introducing yourself? What, your background, maybe a little bit about Other Lab.
Hi, Saul Griffith. I was a little bit late. Ironically, I just wrote this book, Electrify, which is about electrification and fixing climate change. But I just had a blackout in my house. There's quite an incredible thunderstorm outside, but I'm back up and back here. So Saul Griffith, I maybe to start from the beginning. So I've started maybe a dozen companies, nearly all in hardware now. Finished MIT in 2004 and then moved to the Bay Area. And I guess some people would say serial entrepreneur, I might say pathological. That started with a company called Squid Labs that was really 5 guys in a room with no idea what they were doing. That became a couple of spin-out companies. One of them was Instructables.com, which was an early how-to website on the internet that was quite successful. I left that and spun out a company called Makani Power. We were trying to do airborne wind energy that you would describe as heroic hardware. We were trying to build kites that were about the size of 767s that would fly at a few thousand feet above sea level or above the ground, basically fly in huge loops and generate megawatts of electricity. We eventually were able to, that's quite a difficult technology to make work. We did make it work. We tested that in Norway in 2019. And there's a great lesson there. When we started that project, traditional wind power was 20 cents per kilowatt hour, and it was 2006. And we projected that we could make wind powered electricity at 3 or 4 cents a kilowatt hour with these kites. And by the time we made it work in 2019, we were still on track to make it cost 3 or 4 cents a kilowatt hour. But traditional wind energy was itself at about 4 or 5 cents. So our margin for victory had narrowed, or if not been completely spanned. So we shut that down. Have done a number of other technologies since then. Spent a few years writing tools for making hardware, and a lot of that, 2 companies we sold to Autodesk, and a lot of math and algorithms underneath Fusion and some of their CAD products was math that we worked on, very much from the perspective of how do you make snowflakes faster, a little bit like we just heard. So tools that help people make one-offs with the ease and speed of mass production. Since then, nearly everything's been energy or robotics focused, including a solar energy company doing the world's dumbest robot, a solar tracker that tracks the sun. That company Sunfolding is still going and installing megawatts at the moment, which is great. A robotics company called Canvas Robotics, which uses so all of the robotics efforts actually started with DARPA programs. So a lot of our process at Other Lab is start with early high risk research, which typically in the US is funded by government first. So we do a lot of work with DARPA and with ARPA-E. Anyway, our robotics work with DARPA became Canvas Robotics, which does drywall with robots. So drywall is a very dusty, hazardous, difficult thing to sand and paint. And so we have the world's first wax on, wax off robot doing that. Interestingly, the same technology that was underpinning Sunfolding, the solar company, was the underpinning technology behind that robot, and also the underpinning technology behind a company called Rome Robotics, which makes lower body, ankle and knee exoskeletons. We do that for military markets and for medical devices. So for post-knee surgery recovery, for elderly care. And so we have, in fact, the world's first exoskeleton that can provably make people run faster and jump higher, which is pretty fun. Other notable projects. Right now, we actually launched about 3 weeks ago a product with a company called Skyscrape in partnership with Ralph Lauren, and we made the textiles inside the winter jackets for the American Winter Olympic team. So it's a pretty exciting technology. We made, there's about 20 million fibers in your average shirt, which is quite amazing to contemplate. We made every single one of those fibers into a wiggly little actuator that, as the temperature changed, it would curl. And if you get them all 20 million of them working the right way, you can make the jacket get warmer when it gets colder and get cooler when it gets warmer. So I actually feel like that was the most elegant thing we ever invented and brought to market, because it's completely passive. It's just made out of commodity plastics, but yet it does this amazing thing.
Cool. Let me get to a couple questions. That's great. I have a bunch of questions for all of you. No. I have a bunch of questions for all of you, but that's fantastic. Those are all cool things. We will put some links in the chat so you can all jump to some of these companies and see what everyone's up to. Anna, let me start back with you again. So, a lot of, when we think about entrepreneurship, what a lot of us think about entrepreneurship, and I think a lot of our students and other people out there, we tend to think about software. Mark Andreessen, software is eating the world. Not sure I agree with that, but that tends to be where we think. And there are unique challenges with hardware. You sort of are, seen all of that, and now you're on the front end helping, students in your lab sort of envision that. What do you see as some of the unique challenges in hardware that either, people just don't know about? They don't know till they bump into it.
The analogy that I always hear, and I repeat, so I can't take credit for it, is, in software, they use the analogy of you kind of build the plane as it's taking off, and you can actually build it as it's going. With a plane, you have to build it, you have to prototype it, you have to test it, you have to certify it, you have to check it, and then they might let you fly it if somebody's willing to pay for it, if you get the cost right. And so there's just a different time constant in trying things out and getting feedback from users. And then there's just a huge gap between a prototype and something that you can actually hand to the customer. Again, because you have to have the packaging. It has to be right. It has to be usable by tons of people. The downside of it not working can be catastrophic if you have a safety issue. It has to be delivered to somebody. You have to have a way of getting it returned. So just the fact that we're dealing with physical objects, you also have a supply chain. We all know what the supply chain issues are. When you're dealing with software, you're just the level of complexity of getting physical objects built, tested to the customer, and then back from the customer if there's a problem. I just had a recent experience with a very poor returns process. So it's front of mind of like how to emphasize that with my new startups. There's all of that to it. And then just the laws of physics can be really pesty. They're just, things shouldn't break, and we do have to, it's very, you can't violate those laws of physics. And so understanding those laws of physics is the first way to start.
Cool. I like that. Yes. Yeah, we always, when students pitch new ideas, the first test is, does it break the laws of physics? Which sometimes it does, unfortunately. So sort of building on that maybe a little bit, Joy, they don't know what they don't know. Here, can you make me one of these? When folks interact with you and you're trying to maybe shrink that time constant that Anna referred to, what do you sort of see as what people tend to get wrong? And let's make it positive, what they tend to get right also. But when people come to you and they say, I want to make one of these, what are some of the things they don't know that you end up having to educate them on, or they, submitting to your portal and have to change and correct and change?
I don't think this webinar is long enough for us to look. No, jokes aside, I think that certainly for the early entrepreneurs and folks who are most of our customers are enterprise customers who are very well experienced and have good process in place and sort of good hardware hygiene, if you will, in terms of having rigor around the march from a prototype of a new product all the way through to flipping the switch that says it's now ready for production. I suppose that it's also true that some young companies aren't aware that there is this usually quite rigorous series of steps that folks go through. We have data that shows that there are about 14 iterations from concept to production typically in hardware in terms of the number of iterations that a company will go through. Some of those may be attributable to picking the wrong component. Some of those may be attributable to some hairy design issue that placed a certain component too close to another component. Some of it, as Anna pointed out, might be, who knew you were going to have to drop this from 30 feet? And then when we tried that, it turns out it broke. So it's a real gamut of things. But I think that, I think thinking through the process as a journey and thinking about the endpoint and working back tends to make for the best beginning steps. In other words, if you know that you're going to be going into the hands of a consumer at the end of the day, and it will be in a cold place or a warm place or in space or wherever it will be, and then thinking about what you will have to go through to perfect that product, both electrically, which is where we tend to focus, and mechanically, and in terms of form factor, is probably the step that a lot of folks skip because they're so excited about building something. And that little bit of time, that little bit of planning, and then revisiting that as you learn more is something that I think certainly in the startups that I've run has paid off big time.
Yeah, that really resonates. I know Stephen and I have a session coming up on one of our programs around specifications, like what's the end look like kind of thing. So I love those ideas. Saul, we had a little chat earlier. I know you're very focused on clean energy and very focused on solving some big problems. What are some of the unique sort of challenges in the clean energy space when folks are trying to tackle it, whether they're trying to tackle it, in front of the meter, behind the meter, just a small device? What do you see as some of the bigger challenges that one comes across as an entrepreneur that you may not know about?
It's hard to imagine a product that's going to be a significant contributor to solutions for climate change, meaning address a significant segment of the energy world that isn't highly regulated, already competing with an at-scale commodity. And that makes it extremely difficult because you're small and you're tiny and you're trying to break into a regulated commodity market. And then really what that implies and what makes that exceedingly difficult is the mismatch between the timescale of doing a project like that and the timescale of venture money. And this is a pretty brutal summary, but in the real world of venture, most funds have a 10-year timeline. They try to deploy that in 3 years. What that really means is they would like any company they invest in to get to profitability or some milestone of value that they can sell out of their asset in less than 7 years. Most of our energy projects have a couple of year regulatory problem ahead of them, a 1 or 2 year bankability. That means in order to install at scale hardware and connect it to the grid, it needs to be insurable, it needs to be bankable. So there's a whole bunch of other processes that have to be had. And it's nearly impossible to find investors that can invest outside of that 7-year time window. The only companies that I've built that have had exits in under 7 years were they might have been hardware oriented, but they were pure software products supporting hardware. So that mismatch of time is the fundamental problem, and then you need to become an extraordinary storyteller to raise money in the face of that.
Okay, let me go back to Anna. So I know one of the things you're focused on is helping people validate ideas. So how do you do that? I mean, how do you do that now? What's changed? We all have heard of 3D printers and maybe everyone on this call has heard of a 3D printer, a CNC machine, and a laser cutter, I assume, plus all the other odds and ends. I mean, how are people maybe using that to get to a valid model faster, and B, maybe something, to Saul's point, to maybe get up that investor curve a little faster, to not have to be quite as far along, just try and get in front of, try and get the money earlier in that 10-year cycle?
Yeah, so a prototyping strategy, and I really view these as prototyping as opposed to samples or actual products. And I think people need to sort of have a very clear distinction between these are prototypes, and prototypes have a role of testing a hypothesis, answering a question, getting rid of uncertainty, getting feedback about things. So you have to be very intentional during your prototyping rounds to figure out what question you need answered or what value do you need from that prototype. So, if you're doing something and trying to put it in front of a venture capitalist, it's probably going to need to look like a looks-like prototype. It's going to have certain key bells and whistles. The venture capitalists oftentimes aren't going to understand the core technology, so it has to have that whiz-bang look to it. But if you're validating something around a user interface, it may have a very different look. If you're validating your core tech, it may have a very different set of prototyping rules. So it might look like a pile of wires. What I find happens is that human beings oftentimes will substitute a hard question with an easier question. So we substitute what should we prototype with the question, what can we prototype? And what happens is you build the thing you know how to build, not the thing you need to answer a question. So I see a lot of wasted prototyping rounds because you really haven't understood what are my key risks, what do I need to be answering, what are my uncertainties, what are my roadblocks that if I can't get this part to work, it's not going to work, or I can either take approach A or approach B. What is that prototype? What is that test? What is that validation that I need to do to really understand which direction I'm going to go in? And so becoming much more strategic with prototyping. And in hardware, prototyping is really expensive. It's expensive in people cycles. It's expensive in money. It's expensive in time. And it's expensive in focus. So, being incredibly strategic and tactical about how you do that, I think the best companies that I know are the ones that do that well.
Yeah, figuring out what questions to answer. I like that framing. I have a question. I think any of you may want to jump on this. I'm going to start with Joy, but feel free to build on it. So Jeff Grazel asked, after you make a physical prototype, what are the differences, from making 3 units versus 10 units versus 100 units, and I'll say thousands or hundreds of thousands, sort of what are just some of, as a startup, just what are some of the things in terms of maybe the amount of dollars, the amount of skill set, the organizations you interact with? I mean, it's a fairly broad question, so I'll give each of you a chance to maybe think about it for a second, but I don't know, Joy, if you want to take a shot at that, sort of. Sure. How should companies think differently? You've done this for hardware companies.
Yeah. So, once again, I think, I guess my philosophy on this is start at the end and work your way back. If you know that your ultimate volumes are going to be in the thousands or in the hundreds of thousands or in the millions, wherever you fall on that scale will determine your ultimate manufacturing strategy and your potential manufacturing partners and their location, even potentially. Working backwards from that, certainly what we're striving for at Tempo is to make it just as easy to build we really focus on small quantities, sort of 1 to 1,000, roughly. We're not a volume manufacturer. We're not intending to produce millions of anything. We're really trying to perfect the journey from concept to production. And so with that in mind, it's no more difficult to make 3 than 10 than 100. However, as the company designing and building, it should be all about reducing the risk between the first one you build and the manufacturability at the end of the day. And so what you're really trying to do is ensure that you've thought through those milestones that we alluded to before, everything from the environmentals to the drop testing, to the regulations that might apply. And I'm only focusing on the hardware side of it right now. Sam brought up some great points relative to the regulatory environment. And, there may be standards that you have to ensure that you adhere to as you're doing the build, if you're building a medical device or something that's going into space. But at the end of the day, I guess I'll sort of stick with the work backwards from your end stage a lot when you're talking about hardware, because it makes a big difference in terms of how you progress to that stage.
Yeah, I love that. I have so many questions for you also. I'm going to jump a bit here. I want to go back to Saul for a sec. So Saul runs an organization called Other Lab, if I remember correctly. And I think we own one of your spin-out company products, the Other Machine. I actually was one of their Kickstarter backers. So I've been an Other Machine person for a long time. How do you decide what you look at Other Lab? If any of you, we'll put the link in the chat. How do you decide what's an Other Lab project, given all the complexity we've just talked about?
Anything is inbounds, really. And it changes with the, we don't have a model at Other Lab. Everyone says, oh, Other Lab's so successful, what is your model? And I think this may sound a little weird. I think if you have a model, you're adhering to an idea that was relevant when you had that model in your head some number of years ago. So we really look at everything as potentially inbounds. We're very good at math and physics and material science. And so that gives you a pretty broad world purview. The specialties really end up being in energy because that's an important problem, and in robotics because it's hard to find somebody who doesn't like making robots. And robots, under robots, I include CNC machines. So we've actually done a couple of companies and a couple of products in automation. So we have a laser product company, 3D Fab Light, that's doing hundreds of units, which I absolutely concur. You really need to know whether you're making millions of things, hundreds of things, because making one thing is hilarious and fun and everyone loves it. But making either hundreds or millions is a lot of headaches. But how we really decided is, honestly, at the end of the day, is there an individual or individuals who are so passionate about the product that they're prepared to take the time risk of investing 5 or 10 years of their life in bringing that product to market? Honestly, good ideas and good technologies are easier to find than a team of people who have the dedication to take that all the way to market. So I think, Other Lab changes in size because every once or twice a year, 3 to 10 people leave with a company. So we're 30 to 50 people as an organization most of the time. And at best, I think we can produce one good technology company with a good shot on goal a year, with a lot of effort, doing a lot of things. But to get the technology to line up with a team that wants to do it, with venture that wants to back it, that's the limiting factor.
Oh, interesting. So we've had a couple conversations, a couple times, word investments come up here. So Anna, circle back to you. I mean, you've helped companies through all this, from the earliest days till, significant fundraisers. maybe just, especially in the earliest stages, I mean, it's hard, as Joy said, I mean, there's very few people who invest in hardware companies in the first place. Do you have any sort of just rough guidelines of what you've seen investors want to look at, to see in order to put down some money? I mean, besides there obviously being a market, some of the more traditional things in the hardware space, what are some of the things that gives them confidence that this might actually happen?
I found the minds of venture capitalists impenetrable. I look at some of them and go, why did you invest in this? And why did you invest in this? I am an engineer, and so I've yet to figure out the logic of it, to be perfectly honest. I think that there's, from what I can tell, again, not being in that space as much, the product has to resonate with the person who's investing in it, that they have to feel that same level of passion and that same level of engagement. And that passion either has to come from, it's a really cool product that I would want. And you sort of see companies that are littered with those, whether it's the Juiceros of the world or these other ones that looked to the investors like, oh, wow, that's a great idea, but they might not necessarily have done their homework on it. I think that a lot of it comes from the passion of the team. I am continually disappointed in the lack of representation of underrepresented minorities and women and femtech and sort of so either products that are geared towards certain populations. I'm continuously disappointed that our venture capitalists aren't picking up on those products. And I have a number of clients, a number of people that I've worked with over the years who fall in that category, and they're passionate. It's an awesome product. They have product, they've got the market, etc. And yet it can be very, very difficult to gain traction with the venture capital. So maybe I need to get into it.
All right, that's fine. No, yeah, no, that's great. I mean, I think it is a bit of just, from the outside in, it is, and I actually don't know. I mean, I spend a bunch of time in the VC world, and I actually don't know that many companies other than Lux and a couple others who actually take the time.
Lux like selling software with on the back of hardware more than I think they like hardware. Let's be very honest. And we struggled so much with venture capital that we ended up raising our own fund. And I think the only way to understand venture capital is to actually become one, which is the thing you don't want to do. So I'm on the other side of that now. So I think I do understand the structure and the nature of venture capital now, only because we ran a small fund, and our fund will be okay. It won't be a 10x fund, it'll be a 2 or 3x fund, which is reasonable. But that certainly gives you more sympathy and empathy for the decisions that venture has to make, especially around hardware, because we could understand the physics all the time. But then the diligence calls that I'm asked to do for other venture capital companies, you realize they know nothing of what they're, because they're covering, most venture capitalists will cover med tech to climate tech to consumer electronics, and these things are not the same, different laws of physics, different, and so I came to appreciate how hard it is for a venture. Honestly, if you really are thinking about hardware companies, my first advice to any entrepreneur is there a pathway where you can avoid traditional venture? Can you borrow enough pennies from friends and family to get the truly minimally viable product into the marketplace to test it? If only because if you can sell even a few units of anything, that is actually how you raise venture. There's been a tremendous grade inflation in venture capital over the last 3 decades. Used to be that an A round was you kind of had an idea and a skeleton of a team. Now the A round is you're in market and your growth. and meaning you're already selling a thing. So there's a lot of seed rounds now to do what used to be traditionally an A round. So there's a lot of dilution before you even get to the starting gate in venture if you're doing hardware now, which is really why I think, sadly, you need to try and find other options to get to that starting line. Honestly, our best venture capitalists are the lab has been the US government. There is still a huge amount of money in the Department of Energy, the Department of Defense in building hardware technologies. And critically, you can find yourself 2 or 3 years of non-diluting funding that helps you build the team and helps you find product market fit and actually make technology. We try to make sure that the technology actually works before you get off that money. And if you don't, that's a pretty good sign this is not going to work.
Yeah, we've had a lot of folks we've worked with on the SBIR front who've done quite well. You all are in a you're all in a unique situation because of your jobs to see interesting ideas. So I'm kind of curious. I mean, you probably see them at different stages, but I'm kind of just want to go around the group. I'll start with you, Joy. What do you see? What have you seen lately? Just like, oh, that's cool, that's interesting. Oh, I'm glad someone's doing that. Maybe I would be the customer, maybe I wouldn't be the customer, but I think that person's onto something. So I'm kind of curious, just going around the group, what have you seen? What someone pitched you on, or what's a student done, or what's a customer brought to the table? And oh, that's kind of cool. I know you can't give any secrets, and a lot of you are working with folks way before there's any public information, but in the broadest of brushstrokes. Joy, why don't I start with you?
Sure. We have NDAs with most of our customers, if not all, and so I suppose I won't be talking about any of them by name here, but there's a lot of stuff going into space right now in a variety of different ways, which creates a level of complexity and durability that calls for it's sort of the hardest stuff to make, if you will, typically. And so that's been fun and challenging to see. We actually had some boards that we built that went to Mars on the Mars rover. So
wow.
that was sort of fun for us. Maybe because Sauls on the call, clean tech is another area that's near and dear to my heart. Personally, I've actually I sat on the board of a company for a while that was using my former startup's technology to help in data centers. It turns out that one of the highest costs in running a data center is the air conditioning, because the machines all get super hot, and cooling in the data center is one of the highest costs of operation. And also, and that means it consumes energy, which means that lowering that overall consumption is good for the world. And so one company, Vigilant, was using sensor networking technology and AI to be able to optimize the cooling in data centers. Another company that I know of sort of on the investment side is Turntide, and they've created a very low horsepower electric motor for people to be able to replace other more energy consumptive and fossil fuel consuming motors that might be in an industrial environment, in particular, everything from air conditioners to being on some form of production line. And so when people think about clean tech, oftentimes people try and think about the end use per se, but one way that can be, I'm not going to say a shortcut, because I think that Saul's comments are very resonant, but if you can find a replacement technology that fits well in the ecosystem, that in and of itself helps sort of move the ball forward, and there's an ecosystem that could absorb that, and that would be a natural act for them, that's a way that technology can progress a little bit more quickly, potentially, versus trying to build the end solution is build something that somebody can take out, one piece of what they do, or replace something in their current supply chain with something that you bring forward that dramatically improves the sort of the energy profile of whatever that process is.
Yeah, I love that. Anna, you must see some stuff. Anything
So
cool?
I'm gonna tell you about two really cool technologies. One is a Black-owned business, Brandale Randolph, who has 1854 cycling, and he has this really cool sort of goal of creating bikes that can be used by police departments that have all of the community information on the computer. So instead of the police being somebody who is arresting somebody, or it's a confrontational, they are a resource for the community. And the idea is putting these things on the bikes. And he has this goal of building these bikes using labor, women who are just recently taken out or who are no longer incarcerated. And we've been talking about how do you build in childcare? So it's really become not only just about the bikes, but about the community they serve, both on the front end of the building as well as on the use of that product. Another one is Impact Bio, Bridget Hunter-Jones. I just had a conversation with her a couple of days ago, and her product was on Indiegogo recently. And it's a really cool product. So instead of, if anybody's got the Theragun, it sort of is what it is. And this device actually measures the tonality of the muscle before it actually applies the pressure. And they're developing some really interesting intelligence about how to do that. And she's just been recently written up in Inc. magazine, and is doing some really interesting sort of intersection between hardware and data and healthcare. And so those are two that I talked to this week.
Wow.
Yeah, and so I have a policy where women and minority-owned businesses who are in hardware, I'll spend a half an hour, 45 minutes on the phone with people, because I feel as though that's really important to support those communities in the hardware space.
Saul, I imagine you're pitched ideas all the time.
We'll have to talk about the perpetual motion machines.
Yeah.
We see a lot of those. I'm watching the electrification space of everything a lot. I'm really excited by anyone who can move the needle on HVAC. HVAC is pretty boring, so that's heating and cooling systems. I agree with Joy. Things like variable speed drives can have an enormous impact. I get excited by the dull sounding things that move the needle in a big way. I also get, the one company that I talked to recently, they're doing great. They're an Australian company that are using drones to string transmission lines, take a hell of a lot of the dangerous labor out of running these electric lines across countries. That was really exciting. I don't get very excited by space. That's just, every nerd has a different thing. I really get excited by protein engineering. And I'm really excited by a bunch of the ways that protein engineering is moving beyond just pharmaceuticals into commodity materials, into alternative foods. And I think there's a lot of interesting things going on in that space broadly that excite me. It's an interesting time. But yeah, the things I get excited about the most are like people who deeply ask the question, well, we're going to need a lot of batteries to balance the grid. Is the best place to put them really in the car, really in the side of the house, or are there other places where it would be better? And I think it's like trying to go back to the basics, understanding now, for example, in energy, that kind of the ingredients are now all getting mature. It's going to be a lot of solar, it's going to be a lot of batteries, it's going to be a lot of wind. How do you mix those in interesting ways, slightly reformat the solar so it can go on more surfaces than the surfaces it's currently going on? How do you recycle? We will not succeed unless we build recycling communities around all of the components of these things. Who's going to do that? So I get excited by those things. And what are the unique combinations of these things? Yes, what is the software layer that's going to glue all of that? There's going to be literally 1 billion machines in the US that are going to be electrified in the next decade. How do they all connect and talk to each other to balance the grid? It's a very exciting space, provided you have the patience to sort of look at the machines underneath the whole electrification of the US.
Cool. Anna mentioned something and I know Joy is very interested in this space. So Joy, you've been involved in funding female founders. You saw the problem a lot earlier than most people saw it. I mean, now there's a lot of energy in that space, no pun intended. Not that the problem is solved by any stretch, but could you talk a little bit about your work there?
Yeah. So, in fact, the way I was introduced to Tempo was I was part of an angel investment group called Golden Seeds, and Golden Seeds is still very active and has chapters in I don't know how many cities, but at least 4 that I can think of off the top of my head. And they focus explicitly, and all of the folks who are involved in angel investing there are looking to do seed investing in women-led companies, whether it's the CEO, somebody in the C-suite. It doesn't have to be the CEO. And obviously, they don't invest in everything that comes along, but there are a number of those kinds of groups that are really trying to, elevate the visibility of some of those women, and also will provide some coaching. I know that I went to many a session where we saw entrepreneurs and provided them feedback on their pitch, et cetera. So, put in a plug for Golden Seeds, and for those of you who are on this call who are women entrepreneurs, there's a bunch of folks out there who are interested in seeing you succeed. If you can find them, latch on to them and try and spend some time and see if you can get some good advice from folks who are willing to give it.
I probably don't look qualified to talk on this issue. Our venture fund backed 3 women-led companies, so about 40% of our fund.
Fabulous.
They outperformed. They were, without exception, fantastic leaders, fantastic entrepreneurs, really dedicated, much better organized than the male CEOs, I think would be the single guiding principle. What was sad to me about watching their journeys alongside our male CEOs is how much friction they had with the rest of the venture and business community as they went through their journey. And I think I absolutely would love to see a lot more women take this path, but it's still there were 3 hurdles for those wonderful women for every 1 hurdle for our male CEOs. It's still that much more brutal out there, particularly when you're going up to retail venture. It's still extremely sexist, to be honest.
Yeah, my colleague here, Andrea Polito, runs an organization called We Cornell Women's Entrepreneurship. That sort of, just one more person. She's a successful entrepreneur herself. One more person trying to work through this problem.
I think we are winning, but it's a long game.
Yeah, yeah. We're getting close to the end. There's a couple quick questions here. So one question, I'm not sure there's an answer here, but maybe I'll give it a shot. Keenan Valentine asked, sort of general rule of thumb, maybe using Joy's working backwards. If you're going to make something that you're going to make 100,000 of a month eventually, what's it going to cost to get a proof of concept of that going? What might it cost to get an MVP going? And then just sort of, I think there are a lot of folks on the call who don't know whether, you can get a proof of concept then in $10 or $10,000 or $100,000. So I'll give each of you a shot. Maybe Anna, I'll ask you to go first. And I'm not sure there's an easy answer here, but when someone comes to you with an idea, I'm sure you have students do this all the time. Like, how do you give them some guidance here?
Well, I think understanding sort of what you're going to have to spend all of your non-recurring engineering and having a really good sense of what that's actually going to involve is number 1. Number 2 is focus on really good design as early as possible. The more you can pull out cost early on, the more you can think about clever ways to do it. People have this unrealistic expectation of, if my proof of concept cost me, $50 at production rates, I can pull that down by 25. When you double the volumes, or you go to 1 million, you might get 15% if you're really, really lucky. So people have an overblown sense of the volume reductions as you go up. So really good design for manufacturability reviews, talk to your contract manufacturers, get that cost and the design solid, as that's built in, and you will be paying for it in that design. You pay for it every time you build it in cost, quality, and schedule.
I'll ask the same question, Saul, or do you have any sort of rule of thumb?
I've built a lot of things covering medical devices, aerospace, robotics, energy, and a couple of things really stand out. Paying real salaries to real engineers in the real world. Our budget for all materials and all of the things you have to buy and make for all the products is always between 12 and 20% of the salaries you have to pay, irregardless of what you're building. For $50,000 to $100,000, we can build a working model of a thing that proves the physics or the fundamental that this will work. That will prove it to ourselves. To build the thing that you can prove to venture capitalists is always about $500,000, and then you're $1 to $2 million away from something that might be your minimum viable launch product. And then everything from there gets more expensive. But I think roughly there's sort of this $50,000 prove it to yourself, $250,000 maybe to $500,000 to prove it to someone else, and then $1 to $2 million to prove it to somebody who's willing to open their wallet and pay for it.
Thanks.
I would agree that's the right scale.
Good answer. Joy? Yeah.
They said it all. I'll thumbs up my
right.
co-panelists.
All right, we are coming to the end. And I want to, first of all, thank you all for taking the time. I know you're all busy, and I really sincerely, Cornell will appreciate it, and I personally appreciate that you all made the time to join us today. There was one question that I'll answer as a wrap, and that question was for our programs, our early stage programs, where do you need to be? You need to have an idea, and the idea can't break the laws of physics. That's really or chemistry. So as long as you're not breaking the laws of physics and it involves atoms, it can involve bits also, but it involves atoms. We have early stage hardware programs. We're going to put up, if the slide isn't up now, I can't tell. We're putting up a slide. There's an information session tomorrow about our programs. They run here in Ithaca during the summer. We'd love to host you, whether it's you or someone you know who's looking at a hardware idea. If it's a hardware idea, you're going to end up with a copy of Anna's book. If you're making something electronics, then hopefully we're going to point you at Tempo. And if it's at the energy space, who knows, maybe other lab will want to take a look at it. So I thank you all for your time today. I thank you all for joining us. And if you have any questions, just reach out. I'm happy to chat with anybody about hardware ideas. Thank you all.
Thank you.